You good?
Yeah.
Well, this is our demo, basically on Smart Power. What we'd actually designed this semester was a user interface that actually incorporated the idea of being able to give the consumer more control over the appliances in their house. To basically come up with the idea to send in real-time data from the power company to get an exact kilowatt hour price, and allow the user to be able to see the pricing on a real-time atmosphere. To do this, we created the interface. The interface would be tied into a logic control. We didn't get to the point where we found a logic controller that could be used in this system. We looked at Zigbee Electronics. They had a 120 volt receptacle that was dual controlled, that could be controlled, and also showed things like power, wattage, voltage ratings, and etc. When we first started off to do this, we built a demo house. The demo house was found to be a pretty difficult thing to do. We mainly focused on using heavy loads and the heavy load devices in a house, like a dryer, range, most of your 240 volt AC appliances. Let's see. The model that we come up with was just based on the summer consumption. We based it on the fact that we done a 24-hour day, and we just assumed certain appliances would be on at a given time to actually develop a higher peak at certain points. The main thing is we wanted to be able to see these peaks, to actually observe it, and then be able to try to find a way to lower demand in the overall system. The main reason for lowering demand in the system was for the main fact that it actually causes less strain on the grid and the system itself, and also avoids situations like blackouts.
As you can see here, we got the graphs that Mike was talking about. This is an average demand graph with a person that works, say, a 9-to-5 job. They wake up at 7 o'clock and they turn on their water heater, etc. And the peak demand rises at that time. And while they're at work, you can see it kind of flattens out. But when they come home and get off work, the peak gets real high again because they're using all their devices, like making food or what have you. And this is where the cost is real high for the consumer. We were looking to try to cut that out, try to save the consumer as much money as possible. And we did that here by allowing the user to have power company incentives to change when they use their heavy demand devices, and then allows for the demand to be cut out, lowering the cost lowering the cost to use their devices over that amount of time.
Probably another thing we also looked at in the project, we wanted to be able to do a wireless IP address from each one of the loads. This was actually designed in our system. It's more or less known as an addressable system. What it actually does is we wanted to be able to send an address from each individual load wirelessly to be able to find the location of where the device was at. This would allow the user to actually enter the location, and once the location was known, then the user would be able to see how that device is responding through the demands.
The real-time data that we used from the power company was based on First Energy Prices, who just recently took over Allegheny Power, to help us find these kilowatt-hour graphs.
Alright, let's go over to interface. Right now, this is what we developed. We didn't get as far as we would like because the actual system needed an addressable IP address and such, and we would need more of real-time data. Right here is just a basic mock-up of what it could look like. We established where we had a place for the appliances to be selected by the user based off of what they had. We actually would probably go to somewhere where they would allow them to enter their application's name, wattage, and stuff. As far as the calculations go, we base calculations off of the washer, dryer, things we know that are maintained. This would be your average daily usage based on the pricing scheme for the summer for just a single day. Pricing we had was is actually right here. That has it in for each day where it changes, 1 through 12, January through December. Based off of that, the price fluctuates, as you can tell, gets higher in the later months. Due to heating is mostly on electrical around here. So that's one thing we did do as far as the user interface goes.
Okay.
That's about it. About all we can do.
Okay.